Okay, so question 9. In 2014, the coffee artists designed a new and improved capsule as part of the Vertuo range, which has a larger diameter compared to the original capsules. Its diameter measures at 7 centimeters and is still a hemisphere in shape. What is the volume of a Vertuo capsule? Well, look at the image that I've got next to question 9 or question 9A, and you'll see that the new capsules look rounder. They look like they take up more space, okay? Now, what I don't want you to get confused with is that in question 1 or any question that we were dealing with where we were calculating the volume or the total surface area of the original capsule, I gave you that, well, the question gave you that measurement in terms of its radius. Now, with the new and improved capsules, they're giving you the diameter. So you can't get confused with the wording there, because if you don't read the question properly and notice that we're not dealing with the radius like we were with the original capsule, your measurements will be all off, okay? So it's telling us that the new capsule has a diameter of 7 centimeters. Now, if I draw a hemisphere like so, that means that the diameter is 7 centimeters. So from here to here is 7 centimeters. So diameter means whole way across, okay? I'll just draw this as a 2D version because that might look a little bit confusing. So from here to here is 7 centimeters. Okay, its diameter is 7 centimeters. So what's the volume of this? Well, what's our formula for the volume of a hemisphere again? Volume of a hemisphere equals 2/3 pi r cubed. Okay. The diameter is 7. So what's half of 7? 3.5. So our radius is 3.5, which means half of this is 3.5. So we're putting 3.5 into our formula. So V equals 2/3 times pi times 3.5 cubed. Equals 89.80 centimeters cubed, because we're dealing with volume. Okay, so you're basically doing exactly what you did in question 1, but this time you're doing it for 3.5 instead of 2.1. So you should be able to do this, okay? For question 9B, what is the total surface area of a Vertuo capsule? Well, same shape, but this time we need the formula for the total surface area of a hemisphere. Now, if you go back to my YouTube video that shows total surface area of a sphere, you'll see that I talk about how to get the total surface area of a hemisphere and get the formula for a hemisphere from the formula of an actual whole sphere itself. So if you want to go back and see how I get this formula, then watch my YouTube video on that. If not, you can just trust me and believe me when I say that the total surface area of a hemisphere is 3 pi r squared. And that's the formula we need to deal with. And if this is something that you can't remember, this is where you pause me right now and you put this formula in your exercise book. Total surface area of a hemisphere, okay? So a half. Radius is still the same, so I'm just putting 3.5 in here instead now, and I get squared because we're dealing with total surface area. Okay. C, how much extra coffee can a Vertuo capsule hold compared to an original capsule? Ensure your answer is in grams. So how much extra coffee can the new capsule hold compared to the original? So if we're talking about how much it can hold, we're talking about the space inside of the capsule that allows the coffee to sit in. So how much space inside is each capsule worth so that it can hold whatever amount of coffee that it can. So when you see how much can it hold, we're dealing with volume. How much space inside of the capsule is the coffee actually taking up? How much can it take up? Okay, so we need to compare our answers from volume. Now to do this, you need the volume of the Vertuo capsule minus the volume of the original capsule. All right. So you'll find the answer to this in question 9A. And you'll find the answer to this in question 1. So you're taking your answer from question 9A and 1 and subtracting them. So we've got 89.80 minus 19.4 . Now, if we were dealing with volume, the answer would be 70.4 centimetres cubed, but we actually want grams. Now, centimetres cubed is the same as millilitres, is the same as grams, okay? They're all equivalents. So because they're all equivalents, your answer would be 70.4 grams extra. Okay, that's the answer to question C. All right, then we move on to the last question. So last question is, you believe that with all your newfound knowledge in measurement, you can design a better sleeve for capsules than the masterminds at Nespresso. Come up with an entirely new shaped packaging design that is a different shape to a rectangular prism. So 10A, draw a net or 3D drawing of your new packaging. You could literally do anything, all right? Just as long as you draw it properly. Okay, so you draw what you feel more confident with. Would you rather draw a 3D version of the shape you're thinking of, or would you rather draw a net? You do what's easier for you. You could have a cylinder, so the pods could all stick up like this. You could even have a cone. That'd be cool. That'd be different. All right, you could actually have a cone. Or it actually could be sitting the other way, like this, and that could be the packaging. So you lift it up like this from the top. Okay. What other shapes could we do? We could do a square-based pyramid. That would also be different. Okay. Not really seen widely. I mean, the cylinder would make most sense because of the shapes of the capsule, especially. Or you could do a whole entire sphere. So you could try and market the fact that you're going to put all the pods in a sphere because their own shape is a hemisphere. Or, better yet, why don't you think of a design where it has the packaging as a hemisphere and all the hemisphere pods just are loosely inside of the big hemisphere ball? All right, there's no right or wrong for 10A. Just as long as you can draw me the shape and you can justify why you would use that shape, then it's fine. There's no right or wrong. Just as long as you can draw it properly, net or 3D version, then you'll get the answer right. And question 10B is calculate the volume of the new packaging. So whatever shape you decide on using, you need to use the volume of that shape to calculate how big it is. Is it more effective than the original? And then you also do the same for question 10C, but this time you're working out the total surface area of the whole entire packaging. So what you need to do is think about what measurements you're going to use for each of these shapes. How is it still going to hold the 10 pods per sleeve? How is the sleeve going to fit in the packaging? So then when you think of it like that, you think, oh, well, sleeves aren't really going to fit inside a hemisphere or a sphere. I mean, you could put the sleeves sitting like this in a cone, and even in the pyramid, they can all be sitting upright. To me, it makes most sense to use a cylinder, but yeah, up to you, okay? But with question 10B and C, you just work out the volume and total surface area of the sleeve and for the capsules in terms of what shape you decide on using.